Hello my fellow organickers, welcome to Organic Chemistry 1. This video will cover the topic of Lewis dot structures. Many of you probably remember this from General Chemistry 1. All the rules you learned there still apply, but we will focus on organic molecules in this course. Lewis dot structures are structures that show the bonding between atoms of a molecule and the lone electron pairs that may exist in that molecule. We draw Lewis electron structures for covalently bonded molecules. To write Lewis dot structure, we need the periodic table. Periodic table gives us the useful information about the number of valence electrons. For example, carbon belongs in the fourth group of periodic table and therefore has 4 valence electrons. Sulfur belongs in the sixth group of periodic table and therefore has 6 valence electrons. So let's get to it. We will start with Lewis structures of the atoms. In order to do this, I will randomly choose element X that has 5 valence electrons. We will first place single electrons on each side, top, bottom, left, and right. That accounts for 4 electrons. Any leftover electrons we will place on either side and pair it with existing single electrons. Now let's do a couple examples. Hydrogen atom belongs in the first group of periodic table and it has only 1 valence electron, so that's easy. Carbon, for example, has 4 valence electrons and we will place them around carbon atom the same way we used to do it before. Chlorine is in the 7th group of periodic table and it has 7 valence electrons. First we will place 4 single electrons on each of the sides, top, bottom, left, and right, and then any leftover electrons, which is in this case 3, we will pair them with the existing single electrons. Now let's do Lewis structure for diatomic molecule. We will start with writing those two atoms separately the same way as done before. First we write one bromine atom with 7 electrons around and then the other. We see that both atoms are missing 1 electron from achieving the octet. We can simply rearrange the atoms and solve this problem. Now, 2 bromine atoms are sharing electron pair. We will do the same thing for oxygen molecule. Oxygen has 6 valence electrons, so we will have 2 lone pairs as well as 2 single electrons on each oxygen atom. If we rearrange atoms, we will be able to pair 2 electrons but not the other 2. What we can do further is remove single unpaired electrons and move them between the 2 oxygen atoms, and this way we can make a double bond. Now each oxygen atom has 8 valence electrons around and therefore octet is achieved. Each electron pair can be represented with a dashed line and our final structure would look like this. Let's write the Lewis structure of molecule methane, CH4. We will write all the atoms involved with their valence electrons. 1 carbon atom with 4 valence electrons and then 4 hydrogen atoms with a single valence electron. Now we will rearrange atoms so that each atom is happy. Carbon atom will fulfill the octet, whereas each hydrogen will have 2 electrons around and achieve the configuration of the closest noble gas, which is helium. When we write Lewis structures of ions, we have to be careful to include electrons for each negative charge. For positively charged ions, we would remove electrons for each positive charge. Here, we will have to write atoms with their respective valence electrons. Carbon with 4 valence electrons, 3 oxygen atoms with 6 valence electrons, and then add 2 additional electrons because we have a charge of -2. Now we can play with those atoms and try and rearrange them so that each carbon and oxygen atom is happy and fulfilled. We can move the first oxygen here on top, move the second oxygen here on the right, and then the last oxygen can go here on the bottom. Now I have to place those 2 additional electrons somewhere. I can place the first one on first oxygen and then the second electron on the other oxygen. In this situation here, we have first oxygen and the second oxygen that have 8 electrons around and fulfilled octets. On the other side, we have this middle carbon as well as a third oxygen that have only 7 electrons around and therefore they don't have fulfilled octets. What we can do to rectify this situation is remove single electrons from carbon and oxygen atom and then move them between those two atoms so that electron pair is being shared between carbon and oxygen. Now all 4 atoms have 8 electrons around and therefore fulfilled octets. By replacing the shared electrons with dashed lines, we will get this final formula here. Let's not forget this ion has a charge of -2 and we will have to place this molecule into brackets and indicate that negative charge. This previous example is a good introduction into our next topic, and that is a formal charge. By definition, a formal charge equals to number of valence electrons minus the sum of shared electrons and non-bonding electrons. Let's bring our previous example. Let's take a look at the carbon. Carbon has 4 valence electrons and it has 4 bonds around, which means it shares 4 electrons, and there are no lone pairs or non-bonding electrons around. So, by using the formula, formal charge equals 4 valence electrons minus 4 shared electrons. Formal charge, therefore, is equal 0. Let's do the same thing for oxygen here. Formal charge equals number of valence electrons, and for oxygen we know, since it belongs in the 6th group of periodic table, it has 6 valence electrons, minus sum of the shared electrons and non-bonding electrons. Oxygen here has only 1 bond around, which means it has only 1 shared electron, and it has 6 non-bonding electrons. Therefore, formal charge equals 6 valence electrons minus 7 electrons. That means it has a formal charge of -1. For the second oxygen here, we will apply the same formula, and by doing so, we will determine that that oxygen also has a formal charge of -1. For the third oxygen, we will have 6 valence electrons again, minus sum of the shared electrons and non-bonding electrons. For the shared electrons, there are 2 bonds around oxygen, and therefore we know we have 2 shared electrons. Also, we can see that there are 4 non-bonding electrons. If we put that all into a formula, that means that formal charge will be equal 0. If I rewrite the previously determined Lewis structure, we can place the negative charge where it belongs, and that is on this oxygen here and this one here. Fun fact of the day: Lewis dot structures got their name after the scientist who came up with those. He is also known for the discovery of a covalent bond. Professor Lewis was nominated for a Nobel Prize 35 times, but unfortunately never won.